discussion about the real numbers. First thing we will be discussing is the fundamental theorem of arithmetic. Fundamental theorem of arithmetic says that every composite number can be expressed as the product of prime number, and the factorization is unique, but the order of these numbers can be different. For example, see, you can see here 6 can be written as 2 3, 2 into 3 and 3 into 2. 18 can be written as 3 into 2 into 3, 3 into 3 into 2, 2 into 3, 1. So we can see that every composite number can be expressed in the form of the product of prime numbers, and this factorization is unique. So next theorem we will be discussing is that p is a prime number, and if integer, then p divides a square. If p divides a square, then p automatically divides a. If p divides a square, then p automatically divides a. 81, so example, 81 is divisible by 3. That clearly means 9 is also divisible by 3, because 9 square is 81. Clear? So let's move to the next line. Here let's see some example. We will use the factorization prime factor method to find HCF of this given number 90 and 144. First we will do the prime factor of 90 and 144. What we will do? We will write 90 and you will use the LCM process. 2, 45, 5, 9, 3 and 3. So factorize into form of 2 into 5 into, so we can write it into 2 5. So we can write it into 2 5 into 3 square, and 144. Similarly, 144 can be written as 2 to the power 4 into 3 square. And so while calculating HCF, we will see the minimum repetition. While calculating HCF, we will check the minimum repetition. So here minimum repetition and number should be common in both. So 2 is here, 2 is here. What is the minimum repetition of 2? 1. So 2 is occurred one time in 90, so HCF it comes 1. 5 is in 90, but it is not in 144, so explain it. So we will eliminate 5. 3 square is in 90 as well as in the 144, so we will write 3 square. So our HCF will be 18. Similarly, in form for the LCM, so what is the maximum number of repetition between 144 and 90? 2 to the power 4, so we will write 2 to the power 4. 3 square is common in both, so 3 square. Now 5 is in 90 but not in 144, so maximum repetition of 5 is 1 times, so we will write 5 also. Multiplying this, you will get your LCM, that is 720. Now here is an important sum. It is called root 3 is a rational number. In order to prove that, what we will do, we will take on contrary, root 3 is rational number. So if root 3 is rational number, then root 3 can be written in the a by b form, where a and b are co-prime. That is HCF is 1. So by cross multiplying, we will get that a is equals to b root 3. Squaring both sides, 3b square equals to a. That is 3 divides a square, and that means 3 divides a by the theorem we just read. The first class I have discussed about the divisibility theorem. That clearly means a is equals to 3c. So a square will be 9c square. So we will put the value of the a square here. So it will be the value of this a square here. So it will become 9c square, that is b, and that it will become b square equal to 3c square, that is 3 divides b square and 3 divides b also. So from here you can see that the HCF of a and b is 3, but we have taken the assumption that HCF is 1. We have the assumptions that HCF is 1, so our assumption is wrong. So we can say that root 3 is a irrational number. So this is the A for class. We will discuss that in next.